All right, so this is the pre-cal review that you got last week. I'm recording, so I'll record in all the classes. So if we don't get to some questions that you have, you can go back and watch the videos. So again, like I just said, I converted this to a Word document so that I could write on it digitally, but sometimes that makes things show up oddly. So there may be a couple things we have to adjust as we're going through this. So this first section, it tells you the TEK, okay? This is the Texas Essential Knowledge. This is what you're supposed to be able to do. This type of problem is testing you on. It says graph functions including exponential, logarithmic, sine, cosine, rational, polynomial, and power functions and their transformations, including A times f of x plus d, f of x minus c, f of bx for specific values of a, b, c, and d in mathematical and real-world problems. So that's what this first grouping of problems is going to be testing you on. And I can already see it reformatted this oddly. This was supposed to be 2 to the power of x. I'm going to fix that. You have it on yours, right? It's just that it did it weird when it converted. So 2 to the power of x. And so this is 2 to the power of x. And then the plus 3 is not in the exponent. Okay. And then we have log of x minus 2, sine of x plus 1. So I'm going to star those that are the trig graphs because those are the ones that I told you we did not cover graphing trig functions yet. So on the test, these will not hurt you if you get them wrong, but they will count as bonus if you get them right. So I'll still explain how to use the calculator to do these. We're going to do these in January without a calculator. We're going to do this by hand. But for this test, you get the graphing calculator, the Desmos, like the full function calculator, the entire test. So a lot of what we did this year without a calculator, there's going to be shortcuts and ways you can do it with the calculator that will make it simpler than when we initially learned it by hand. Okay, so for number 1A, it says given the graph of 2 to the power of x, they want us to graph 2 to the power of x plus 3. So we need to remember that plus 3 outside the function, what type of transformation is that? What does that do to our graph, that plus 3? Say it again. Up 3. Okay, so if you have something added or subtracted on the outside, okay, this is what that's comparing to. The plus, oh, did they not list the plus d? Oh yeah, it's right there. That's this format. When you have plus d outside the function, that is a vertical shift. And so this one is up 3 because it's plus 3. So in this graph, for 1a, they have the parent function graphed. We just need to shift this up 3. If you don't remember what the parent function is on the test, go to the calculator and type it in and look at it, get a visual. On the test, you'll be able to just go type in this 2 to the power of x plus 3 and see what that looks like. That's all you'll have to do. So I'm going to take this intercept that's normally at 1 and go up 3. Okay, and you can take any of the points on here. So this one and go up 3. Okay, and then get your new curve. Remember, exponential has the horizontal asymptote at 0. So that horizontal asymptote has moved up 3. So at 3, there's a horizontal asymptote. Now for B, you're starting with the log parent function, okay, which is the inverse of exponential. So that one has the vertical asymptote at 0 here. And what they're doing to this graph is minus 2. Now that -2 is on the outside of the function. So, oops, thought I got my highlighter here. It's the same d. It's a plus or minus d on the outside. So this time, this one is going down 2. Oh my gosh. Like a super delay on switching tools up there. So we're going to take that log function and shift it down 2. So that x-intercept is going to come down 2. And then this value can come down 2. And you can just put your new graph there. Now, that didn't shift left or right any, so my vertical asymptote didn't shift. It's still at 0. It just shifted down. All right. Then the part C, this is the one that I put an asterisk by. This is the sine graph. If you type this into Desmos, sine y equals sine of x, this is the graph you get. It's a wave, and it goes on forever. It just keeps making this wave forever and ever. And it wants to know, well, what does this +1 do? Again, where is that 1? Is that in place of A, B, C, or D? D. So this is another one that's a vertical shift. That plus D is just shifting your graph vertically. So this one is going up or down? Going up 1. So I just have to take all of these points that I see and shift them up 1. So it makes the same shape. It's just literally shifted up 1 unit. Now D says, given the parent function f of x, describe the transformation f of x plus d. So this one isn't graphic. This one isn't giving a specific type of function. It's just saying f of x in general. What does that plus d do? What did we just witness in part A, B, and C? What does plus d do to the graph? Yeah, it's a vertical shift. So it makes it go up if it's positive, or down if it's a negative d. So you just need to know that plus d. Oh my goodness, it didn't switch again. That plus d is your vertical shift. Good for that one? All right, so 2 is the same teak, except this one, oh my, that graph didn't copy over nicely at all. Holy crap. Okay, cool. Let's go. Let me grab that here and copy that over. Oh my gosh, paste. There we go. This PDF converter from Word or from PDF to Word leaves a little bit to be desired. Okay, those look a little better. So given the graph of f of x equals cosine x, so that's not supposed to be off x, it's supposed to be f of x equals cosine x. We want to graph this one, and it says it did not convert that pi fourths nicely. Minus pi fourths is what is there. This is 1 over x plus 2, and that's just 1 over x. Then we got x cubed and x minus 4 cubed. Okay, so now notice what's happening in all of these functions is not the plus d. This time it's minus c. There's something happening inside the function. So you can see that minus pi fourths is inside, excuse me, inside the trig function. You can see that this plus 2 is inside the denominator with the x. You can see that this minus 4 is inside the what is being cubed with the x. So all of these are practicing the x minus c transformation. What transformation is that? Before we even try those, what is minus x minus c? What does that minus c do? Say it again. Yeah, this one's a horizontal shift. So the plus d was a vertical shift. This is a horizontal shift. Now, it's the opposite of what you think. When it was plus d, that was up. If it was minus d, that was down. Here, it's the opposite. If it's minus c, that's actually shifting to the right. And if it's plus c, that's actually shifting to the left. Okay, so it's the opposite direction. So they give us the graph of cosine to start. This is really similar to that one of sine that you just saw. And again, for level classes, we did not cover this yet. So these will not count against you on the test. If you are in honors and watching this video, you do know how to do this. We have covered this. And these questions will count. All right, so you have the cosine parent function, and we are shifting it. It says x minus pi fourths. So that is actually going to be to the right. Excuse me, to the right pi fourths. So you can see on your axis, this point is labeled at pi halves, and this one's labeled at pi. So pi fourths is going to be halfway between 0 and pi halves. A fourth is half of a half. Okay, so that's every 2 squares is a half. So we're going to take all of our points and shift them over 2 squares. So that high point is going to shift to here. This point that's a 0 is going to shift to here. This point that's a 0 is going to shift here. And this low point is going to shift. Is that 2 squares? 1, 2, 3, 4. Oh yeah, we can't see that one there. 3, 4. Don't know if that just didn't transfer over very well. Oh yeah, it's right here. So that low point is going to shift to here. So then we can graph the transformed function next to that. Sorry, can't get rid of this tickle in my throat. All right, for B, you're starting with the rational function, 1 over x, and the c is, it says x plus 2. So it's going to be actually, again, to the left. It's the opposite direction that you would think. So this is all going to shift left 2. So remember, your rational function has an asymptote, a vertical asymptote on the y-axis. That asymptote is going to shift left 2. So that asymptote is going to show up here. And this turning point is going to be here. And this one is going to be here. So your new graph ends up looking like this. So shifted left 2. If you want to write those, what we're doing, we went right pi fourths. Here we're going left 2. What's going to happen here to this cubic function? What is that -4 on the inside going to do to our graph? To the right 4. So our cubic function has a point of inflection at the origin, but we're going to shift that to the right 4. Okay, and then to the right and left of that, it's over 1 up 1 or over 1 down 1. So those are also going to have been shifted with it. So this is the new cubic shifted right. Oh, didn't get my 4. 4. Oh, I did get my 4. It just wrote it down here. That's weird. All right, we feel okay about those transformations. Plus D is a vertical shift, minus C is a horizontal shift. Takes it way back to unit 1. It actually takes it back to algebra 2, even algebra 1 perhaps. Oh, another graph that did not transfer well in that conversion. Bless you. All right, so this TEAC is graphing exponent. It says graph exponential, log, rational polynomial, power, trig, inverse, and piecewise functions. So this one is a graphing TEAC. This is making sure that you can graph. So I think that is supposed to just be this exact same graph. All of those are supposed to be the same graph. Very strange. Let me go ahead and copy that better picture over for that one. Oh my gosh. Here we go. That one looks okay. I need to replace this one. Okay. So this first one, number 3, tells us, given that the parent function f of x is a times b to the x minus c plus d. So that is supposed to be a power of x. I'm going to just rewrite that. It didn't transfer well. Times b to the power of x minus c plus d. Okay. They want us to have a is 1, b is 2, c is -3, and d is 4. And they want us to graph any asymptotes using dotted lines. Okay, so when I write this with those values plugged in, a is an understood 1. I don't have to write times 1, it's understood. B, that's my base value, is a 2. That's what's to the power of x. And then minus c. I have a minus, and then the c is negative. What happens when you minus a negative? Yeah, it changes to plus positive. So that's going to be x plus 3. And then your d is 4. So plus 4 down here. So I'm going to list the transformations first. The d being plus 4, we just got through saying that's a vertical shift. And that's going to be up 4. We said that the c value inside is a horizontal shift. And it's going to be the opposite direction of what you would think. So that's going to be left 3 because c was actually negative, but in the equation it shows up as plus. So that's going to be left 3. Okay. Now the a value was an understood 1, so there's no effect. A normally is a vertical stretch or compression, so that's not going to affect my graph. For exponential functions, the b is simply the base value. So we're starting with the parent function of 2 to the power of x. So we have a couple of ways to do this. By hand, you could make a table. You could plug in, okay, you can say if x is 1, if I plug in a 1, that's 4. So 2 to the power of 4, calculate that, add 4, and that's my y value. And I would then plot that point. And I could keep inputting x values. But I don't have to do this by hand because on this test, I get a full-fledged graphing calculator. Okay, I get Desmos. Come on. I simply use Desmos and I plug this in and graph it. So it's y equals, you can write f of x or you can write y, it doesn't matter. And this is 2 to the power of x plus 3. Oops, that needs to still be in the power. Okay, I guess I have to use parentheses to get it to stick in the power. So parentheses plus 3. And then outside the function, not in the power anymore, is a 4, so plus 4. So then you can look at your graph and see where to plot your points. And you can zoom in real close, you can zoom out, however you want to look at your graph. Now this is where your horizontal asymptote would be happening, which is at y equals 4. So I'm going to go back to my paper and plot that at, this is scaled by 2s because that's 10 there. So 2, 4. So this is where my horizontal asymptote is happening. Okay, and then I can see on my graph that my intercept is happening at 12. My y-intercept is at 12. So that would be here. And so then I could sketch that curve. This shifted up 4 and left 3. So that point that on the parent function normally crossed the y-axis, your y-intercept, if it was 2 to the power of x, would have normally been at 2. It has shifted up 4 and left 3. So it ended up right there. So that's the point that was normally the y-intercept. It's shifted up and over. Okay. Again, the graphing ones, you don't actually need to spend a ton of time on these because we learned to do it by hand, but you get to use the graphing calculator. Okay, so I'm going to rewrite this one with everything plugged in that they're asking for. So they're saying A is 1, B is 2. So this is log base 2, because that's the B value, of x minus C. C is a positive 4, so it will remain a minus. And then D is 0. I do not have to write plus 0. That's unnecessary. I do not have to write an A value of 1 because times 1 is unnecessary. Multiplying by 1 or adding 0 does nothing. You don't need to write it. So if you know what your log parent function looks like, what transformation has happened here? What's the only transformation here? It's not going down because this is inside the parentheses. This is inside the function. So this one's a horizontal shift. So is it going left or right? Remember, it's the opposite. This is going right 4. So this is the log parent function shifted right 4. So if you know the log parent function, you can picture that in your head. You simply move that vertical asymptote that's normally at 0. You shift it to the right 4. And again, this one is scaled by 2s. Okay. And your intercept is normally at 1. But if I'm shifting this right 4, that's going to be at 5. Again, though, you get the graphing calculator. So you can just type in log. And then here, if you need a log base, oh, our bell's about to ring. You can enter a different log base, but for the sake of your intercept, the base doesn't affect the intercept because log base anything of 1 is 0. So when I input a 1, you can see here I get 0. So your intercept for all of your logs, your x-intercept is always at 1. So this is just, instead of being at 1, it's being shifted right 4. So it's going to be at 5. And then you have the general shape you can sketch. Okay, so use your calculator. That's an advantage you're getting on this semester exam that you did not have on your unit tests for this stuff. Okay, so I'll continue making videos throughout the day as we go over these, and I will post them all for you to be able to check and watch.